Good afternoon. Welcome back. Today we will be talking about statistics. So this is generally for some seniors who might be in your college statistics course right now. Now you've covered quite a bit. I'm a bit more familiar with where you're at in these courses depending on when you started. So some of our schools start before others in terms of their college courses. But all of you cover very, very similar concepts. So I think whatever we do here will be useful, whether you haven't done it or whether you have done it already. You will do it eventually if you have not. So this is going to be the first day on probability. We're going to start with a situation here. Imagine we have a bag with 6 marbles. Okay, so it's a little bag. It's tied off. There are 6 marbles in here. All right. 1 blue, 2 green, 3 red. And you can imagine this situation. If the bag is closed, right, but you knew that this was the distribution of colors for the 6 marbles, and you knew there are 6 marbles only, you can kind of play through your head like, if I reach in and pull out a marble, what is the probability that that marble, when I open my hand, is blue? What is the probability it's green? What's the probability it's red? Okay. So we draw 1 marble. Probability that that marble is blue is 1/6. The probability that it's green, 2/6, or 1/3. The probability that it's red, 3/6, or 1/2. You can kind of see it. If I color these in a little bit, even better here. Okay. You reach in, imagine the marbles are equally shaped. There's no discernible thing just from touch. So you reach in, you're equally likely to draw any of those 6 marbles. Those 6 marbles have certain colors. 1 of them is blue, 2 of them are green, 3 of them are red. So the odds that you pick each of the colors, well, 1/6 for blue, 2/6 for green, 3/6 for red. You know the denominator here to be 6 because that's how many marbles there are, and you're only drawing 1. So it makes sense. Now, let's change the situation here for a little bit. If you have questions about that, I would recommend doing a little bit of studying just on your intro probability to get a sense of being able to calculate these things. So we're going to change something about this now. So the same bag, instead we're going to draw 2. Okay, and we're going to make a caveat here, without replacement. Imagine for a second, close your eyes, you have this bag in front of you, you draw a marble out, has a probability of being one of these colors, say green, of 2/6, 1/3. If you put that marble back in and then you draw a second one, all your probabilities are the same. If you don't, they change pretty significantly, right? So let's take a look here at what the sample space is. Okay, what is the sample space of all possible outcomes? Well, let's think about it. We're drawing two marbles. They're not being replaced. So we can get a blue-green. We can get a blue-red. We can get a red-green. We can get two greens. We can get two reds. Right, now here, a couple things to notice. Now we can't get BB, two blues, because there's only one blue. We're not doing replacement. So if the blue is in there, it's in there. No chance of getting another one. Now, these outcomes aren't equally likely, right? They're not equally likely. You can think about why. Right, you can think about why. But let's take a look here for a second and look at, I don't know. To the probability of at least one red. Well, it's useful here to actually think about how to visualize what is happening here. And a very, very typical strategy here is what's called a tree diagram. And tree diagram talks about the outcomes, the possible outcomes here. So for example, on our first draw, we have these outcome possibilities. And I've written their likelihoods there. So we are 1/6 likely to draw a blue there on the first draw, 1/3 likely to draw a green, 1/2 likely to draw a red. It's like the first scenario where we're just drawing one. However, now we're not replacing that. We're going to draw, I kind of want to do it in color. I'm going to go back. So 1/6 chance of blue, 1/3 chance of green, so we've drawn one marble. Now the difference here, the important thing here, is that the act of drawing the first marble and the act of drawing the second marble, because there's no replacement, those are not independent. Those are dependent. The second one depends, the likelihood of drawing particular things depends on what you've drawn in the first case. And it'll come to clear right off the bat here, right? If we look at the same possible outcomes here of drawing our second marble, okay. Well, we've already, in this line, in this scenario, we've already drawn a blue. So the odds we draw another blue are 0. There is no blue there anymore. It's in our hand, it's not in the bag. We reach back in the bag, there are no blue marbles to grab. Now, in contrast, there are still 2 greens in this scenario, right? There were 2 greens in the bag. We didn't draw one out. There are still 2, but there are only 5 remaining marbles. So these probabilities change. Okay. Similarly, kind of do both once here, so I don't have to keep changing colors. Blue, blue. Well, we've drawn a green in this middle scenario in the first draw, one green in our hand. If we think about what's left in the bag, well, we have one blue left, one green left, and 3 reds. So the chance on the second one of getting a blue, 1/5. Second one of getting a green, 1/5. And the second draw of getting a red, 3/5. Notice that those 3 do add up to 1. You are drawing a marble out, right? The odds that you draw, the probability you draw a marble out on the second draw is 1. No matter what scenario you're in, because that is what you are doing. You are for sure doing that. So similarly here, there's 1 blue left. Now in this case, we've drawn out a red, so both of the greens are left, and only 2 of the 5 reds are left. So what's nice here about the tree diagram is that we can now imagine or calculate actually this particular outcome, right, of getting a blue on the first, not replacing it, getting a blue on the second, right? And it's going to be 0. We know that it's 0. You can't do that, right? And we can verify it with this nice calculation here where we multiply the probabilities in each phase of the experiment, the first draw, second draw, to get the overall probability. So I'll do some of these ones in black since they're mixed color here. So a blue, then a green, 1/6 times 2/5. That will be what? 2/30, 1/15. Blue, then a red, 1/6 times 3/5. 3/30, 1/10. Now pause right here. We should, to some extent, expect that these 2 that we've just written down should be some of the lowest ones because drawing a blue is rare. So yes, we drew the blue on the first draw. That happened pretty rarely. So this 1/6 is one of the smallest fractions. It is the smallest fraction we'll see in all of these calculations here when we're multiplying individual probabilities. Now let's see here. Getting a green, then a blue. 1/3 times 1/5, so that's 1/15. A green, then green, also 1/15, so we'll do the same calculations. Green, then a red, 1/5 of the time. A red, then a blue, 1/10, 1/2 times 1/5. A red, then a green, 1/5 of the time. A red, then a red, 1/5 of the time. Now let's make note here. This is green, green. This is green, red. This is red, blue. This is red, green. This is 2 reds. Okay. Now notice here, when we count through this, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Seems like 9 possible outcomes. In some sense, that is true. Yes. When we think about the sample space here, if we're not caring so much about order, right, in the sense that yes, it matters in the calculation that we drew the blue first as opposed to second, and the green second as opposed to first, or vice versa. But for our purposes, BG, this one, is the same as GB. Now, that doesn't mean that those outcomes shouldn't be considered separately in their calculation. It just means as a part of the sample space, it's 1. So your probability of getting, let's come back to the probability of at least 1 red, and instead think about all these separate ones. So the probability that you draw a blue and a green is 1/15 plus 1/15, 2/15. Right, to some extent, even writing this as BG is maybe a little bit misleading here. It might be better to write it in words of saying the probability of, after you've drawn both, having a green and a blue in your hand is 2/15. Now, 1/15 of the time, you'll get a blue in the first draw and a green in the second. 1/15 of the time, you'll draw a green in the first and a blue in the second, right? But when all is said and done, having one blue, one green has that probability. So we'll just run through all these actually. So a blue and a red would be 1/10 plus 1/10. And 1/5 likelihood. Probability red-green. Well, that would be RG plus GR. So find them, 1/5 for each. Probability green-green. It only happens right here. That's 1/15. Probability red-red only happens right there. That's 1/5. And you can see these outcomes. 1/5 plus 2/5 is 3/5 plus 1/5 is 4/5, and 1/15 and 2/15 together are the last fifth. So those are all our outcomes. This is a probability space. All these likelihoods add up to 1. Something out of these 5 things always happens when you're drawing 2 marbles out of this bag without replacement. It's a nice check to have if you've calculated, the probabilities of the whole sample space. Do they add up to 1? If they don't, likely you've missed something, especially if you're on the below. If you're above, maybe you double counted or miscounted or miscalculated. So something to think about. And yeah, looking at these is, it's okay, I think. Getting 2 greens is pretty rare, right? There's only 2 greens in there. Getting a red and a green is just kind of, I think, intuitively, looking at the bag up here, pulling a red and a green out of there seems probably like it's the most likely thing, and in fact it is. More likely than pulling 2 reds, even though there are 3 reds, right? Still more likely. Now let's go back then to this question of the probability of getting at least 1 red. So first let's deconstruct what that event means. It means you pull a marble, you reach back in, pull a second marble, you open your hand, you have a red marble in your hand, either red and red, red and green, or red and blue. It's different than asking what is the probability that you have exactly 1 red. Maybe we'll do both of those here, just to clarify. So the probability of at least 1 red would be this 1/5 plus this 2/5 plus this 1/5, 4/5. The probability of exactly 1 red would dismiss this situation, right? Where you got 2 reds. So it's like you open up your hand, you're trying to get exactly 1 red. If you have 2 reds, you failed on that event. You don't have exactly 1 red. But if you're trying just to get 1 red or more, then having 2 is perfectly fine. It fits the scenario, fits the event. Okay. Let's spend a little bit of time, the last bit of today's lesson, thinking about an additional concept here. We'll do more of this next week for certain. Probably at the heart of stuff, although eventually we'll do some distributions and some hypothesis testing as the semester goes on here, maybe once we get into April, mid-April. Let's look at this. So I'm going to write it out in the style that it's probability that the second marble is green given that the first marble was red. So take this into account. You reach in, you draw the marble, you actually look at the marble, the first one. It is red, so it is sitting in your hand. We reach back in, and you're thinking, what's the likelihood that I draw a green? I'm about to draw a green. Well, it's not 2/6, right? Because this, let's say it's this one, isn't in there anymore. So you can, I think you can very visibly see that it should be 2/5. And we can find it, in fact, on our work here. We are on that branch, right? Now, the interesting thing is it is not 1/5, right? It's not this number. That's the probability of getting red then green, right? The probability that at the beginning, right, you haven't drawn any marbles, there's still 6 in there, 1 blue, 2 red, or 2 green, 3 red. And you're thinking, what's the probability that I draw a red and a green? Red, then green. This is different. This is, what is the probability that I draw a green given that I already know I've drawn the red, right? I already know that I've drawn the red. That is 2/5, and it's illustrated by this up here with the Xing out. Well, let me reset here for a second. Now there are formulas. This is called conditional probability, meaning you're calculating the probability of some event conditioned on knowledge of something else. So probability that the second marble is green conditioned on that you know the first one was red. It's different than even asking what is the probability that the second marble is green, because there you don't know that the first marble was red, right? You then would have to add up this 1/15th, this 1/15th, and this 1/5. Those are the scenarios where the second marble was green. The second marble is green, given the first one is red, is only this one, and it's only caring about these scenarios right after this. So let's take a look at a different example. Probability that the second marble is blue, given that the first is blue. Okay, you've reached in, fumbled around, pulled one out, you look at it, it is blue, you're holding it in one hand, or you set it down, however you want to think it, but you do not put it back in the bag, you're looking at it, you reach back into the bag and you say, what are the odds that the one that I draw out here, what's the likelihood that I'm about to draw another blue? Well, take your time with this. I think if you visualize it, if you breathe through this one, you'll get it here. Look at this set of marbles. 1 blue, 2 greens, 3 reds. You've already drawn this one out. Oh, that's funny. Seems to... Well, I'll just erase it. You've drawn that one out. There's no blue left to get. No blue left to get. Probability here is 0. Right, we're in this scenario right there. Can't draw another blue. Already drew it out. It's sitting on the table. Now, what about the probability that the first was green, given that the second was red? Now, here's something very different, right? It's different than the first question here. This is, what is the question, the probability that the second marble is green given the first is red. So you've reached in, you drew it out, you look at it, it's red, you go back in, likelihood of getting a green. This is different. This is a weirder scenario to some extent. This is like you've reached in, you grabbed a marble, you keep your hand over it, you don't look at the color, you take it out, let's say you set it under, a blanket or a little something, that a cloth that you can't see under, you set it under that and put it down, right? So you don't know what color it is. It could be blue, could be green, could be red. But what you do know is, depending on what color that thing is, it changes what's left in the bag, right? So it changes it. So if it's blue, there are still 2 greens, right? If it's red, there's 2 reds, 2 greens, and a blue. Okay, so you reach back in, you draw out. Now you look at the second one you've drawn out. There are 5 marbles left in there. You look at the second one, it is red. Okay, then what was the likelihood that the one under the towel is green? Well, what are we talking about here? We're talking about a very specific set of circumstances. The second marble removed needs to be red, so that's good. This one works. This one works. Those are the three scenarios in which the second was red. Now they have different likelihoods, right? It's kind of tricky here in terms of figuring out then what is the probability that the first one was green. Well, it might feel initially like, oh, it's 1/3, but it's not quite 1/3 because this one, which is the event that we're curious about, green has happened. So like we're about to lift off the towel. What's the odds that it's green? Well, that it may feel like it's 1/3 because there's a BR, there's a GR, there's an RR. But remember, these are differently likely. The BR is less likely than GR or RR. These are equally likely. That is less than that. So what we can do is start to think about them in terms of the same denominator here. So this has 2/10 likelihood, this has 2/10 likelihood, this has 1/10 likelihood. So it is 2/5 chance of getting a G than an R. There's formulas there, we'll get there, but let's at least be able to think about what we're talking about here. BR, GR, RR, all of those events, the second one is red, and we looked at it, but we didn't look at the first marble. So those are our possibilities. What's the likelihood that it's green? Okay. And last but not least, the probability that the first was blue, given that the second is blue. So different than this one. Now we have, again, we've reached in, we don't look at the marble, we put it under a towel, reach back in, pull it out, blue. The second one is blue. Okay. Then what does that mean? The likelihood that there's a blue under the towel is. Well, let's pay attention to when this scenario happens. Blue happens on the second draw right there. Blue happens on the second draw right there. In both of those scenarios, what happened before was not blue. Again, we're running into the scenario where there's only one blue marble. So if we are drawing two marbles without putting that first one back in, there's no chance we're ever going to get two blue. So if we look at the first one and it's blue, then the second one can't be blue. If we look at the second one and it's blue, the first one couldn't have been blue. Right? So it's an interesting set of scenarios. It's useful to maybe play around with the deck of cards while you're at home. That's always a good one to do. If you have a dice that you can roll, that's a good one. Maybe we'll look at dice next week. That's always a nice sample space to look at. We can think about sums and things if we're rolling more than one. But that's it for today. Remember to be checking in with your teachers and coordinators about what you're meant to be turning in still. Make sure you're in communication with your college professors about what their expectations are. These videos meant to assist you as you're not being able to spend as much time in classrooms. So hopefully you find some value from them. Feel free to email your coordinators or me if you have questions, or leave comments on the videos, and I'd be happy to help out. Okay.